everyone, it's Miss Joyce. Today we'll be adding and subtracting fractions with like denominators. Let's start with 2/5 plus 1/5. We're going to use visual models to help us add these fractions together. So let's first represent 2/5 using visual models. We have 2 parts shaded out of 5 total parts. We are adding 1/5. So in our next visual model, we have 1 part shaded out of 5 parts. Let's add together the number of shaded parts. We can see there's 1, 2, 3 parts shaded. So our numerator is going to be 3. In one whole, there's 1, 2, 3, 4, 5 parts. So our denominator is 5. 2/5 plus 1/5 equals 3/5. We can also notice that when the denominators are the same, which means that each of these wholes have the same number of parts to make it up, we can just add the numerators. 2 parts shaded plus another part equals 3 parts shaded, and our denominator stays the same. Let's go ahead and start a subtraction problem. Here we have 5/6 minus 2/6. First, we're going to represent 5/6 using a visual model, so we have 5 parts shaded out of 6. We're going to cross off 2 of those parts since we're subtracting 2. So we're going to cross off 1, 2 parts. Well, we still have 3 parts shaded, so our numerator is going to be 3. And our denominator is going to be the number of parts that make up a whole. There's 1, 2, 3, 4, 5, 6 parts that make up a whole, so our denominator is 6. Notice, when our denominators are the same, so they're both 6, we can just subtract the numerators. 5 parts shaded minus 2 of those parts means 3 parts are still shaded. Let's try with mixed numbers and whole numbers now. Here we have 4 plus 1 and 1/2. Let's first start representing 4 wholes. We can see in the next fraction our denominator is 2, so each of these wholes is going to be broken up into 2 parts. We have 1, 2, 3, 4 wholes. We are adding 1 and another half wholes. So this over here represents 1 and 1/2. Let's first add all the whole numbers. So the total number of wholes that are completely shaded. We have 4 over here and another hole shaded here. That gets us 5 wholes completely shaded. We can see that there's still 1 part shaded out of 2 left over. That's going to be the fraction that goes next to our whole number to make our mixed number. So we have 5 and 1/2. Another way we could do this is by adding the wholes. 4 plus 1 is 5, and then 0 halves, because there's nothing there, plus 1/2 gets us 1/2. Now let's try 2 and 4/8 plus 1 and 3/8. We know that each whole is going to be broken up into 8 equal parts, so we can go ahead and start adding 2 wholes broken up into 8 parts and 4 shaded out of 8 parts, representing 4/8. We're going to add 1 whole shaded broken up into 8 parts and an additional 3/8 or 3 parts shaded out of 8 parts. First, let's add all the wholes together that are completely shaded. We have 2 wholes shaded completely in our first add-in and 1 hole shaded in our second add-in. That gives us 3 wholes completely shaded. Now we can go ahead and add the parts that are shaded. We have 1, 2, 3, 4, plus another 5, 6, 7 parts shaded. So our 7 is going to be in our numerator, and each whole is made up of 8 parts, which is why 8 is our denominator. Notice, before we added, our denominators are already common or like denominators, which means they're both 8. So when the denominators are the same, we can just add across. 2 wholes plus 1 hole gets us 3 wholes. 4 parts shaded out of 8 plus 3 parts shaded out of 8 gets us 7 parts shaded, and 8 stays the same because 8 represents the number of parts in each whole. Now let's try a word problem. Kervin and Isaiah bring in Takis to share after school. Kervin's bag of Takis is 1/4 full. Isaiah's bag of Takis is 2/4 full. If the friends combine their Takis, what fraction of a bag of Takis would be full? Use visuals to help you solve. First, let's create an equation. Well, if we look back in the problem, it says that these friends are combining their bags of Takis, which means they're putting them together. So we're going to be adding the amount that each friend has. Kervin's bag is 1/4 full, so the first addend is 1/4. He's combining it with Isaiah's bag, which is 2/4 full, so we're going to be adding 2/4. Let's use visuals to help us add these together. First, we have 1/4, so we're going to have one part shaded out of 4. We're adding to 2/4, so that means two parts are shaded out of 4. We can see that each whole has the same number of parts, which is 4, so we can go ahead and add these together. One part shaded plus another 1, 2 gets us 3 parts shaded all together. And there are 4 parts that make up one whole, so our denominator is 4. 1/4 plus 2/4 is equal to 3/4. When the denominators are the same, we can go ahead and just add across. 1/4 plus 2/4 gets us 3/4, and the denominator stays the same since that tells us how many parts make up one whole. Now let's try another problem. Trinity rode her bike for 1 3/5 miles on Saturday and some more on Sunday. If she rode her bike for a total of 3 4/5 miles over the weekend, how many miles did Trinity ride on Sunday? Use visuals to help you solve. Well, let's first create an equation. If we look back in the problem, we know how far she rode on Saturday, but we're not sure how much she rode on Sunday. It just says she rode some more. We do know the total amount that Trinity rode, which is 3 4/5. So if we know the total, but we're missing part of the amount that she wrote on Sunday, we know we're going to be subtracting to find out the amount that she wrote on Sunday. Well, the total amount she wrote was 3 4/5. So that's going to be the first number in our subtraction problem. She rode 1 3/5 on Saturday. So we're going to subtract that to find out how much she wrote on Sunday. Let's use visuals to help us here. Well, first we have 3 4/5. So we are going to represent that with visual models where we have 3 holes and 4/5 shaded of another hole. We're subtracting 1 3/5. So let's first cross off one hole since we don't need, since we're taking away one hole since that's the part of our first mixed number. We are subtracting an additional 3/5, which means we're going to cross off 3 parts out of 5. So if we look over here, we're going to cross off 1, 2, 3 parts. Now we can see how much is still left shaded. Well, let's start with the holes. We see that there are 2 holes completely shaded. So the 2 is going to go in the front, showing there's 2 holes completely shaded. Now let's look at this next model that shows a portion or a fraction of a hole. We can see that there's 1 part still shaded out of 5 parts. So a fraction is going to be 1/5. So that means on Sunday, Trinity rode 2 1/5 miles.